Hey there, everybody. It is 2 hours UTC, which means it is time for Astronomy Daily Live. You can call me Cosmic, and welcome to the growing circle of friends who share a common passion for the science of astronomy. So hope everybody's doing well. I thought I thought that I was going to be taking calibration data uh, right now, but I was there's a little patch of not so little a patch of high thin clouds that are gonna really looks like it's gonna be moving in over the next hour or two, and that pretty much blows my uh, chances of doing another um, session tonight. So I'm not under um, any kind of obligation yet to be ready to make observations. I'm trying to characterize this telescope behind me, see what the limitations are. Um, Also, just learning how to properly run this scope, given the limitations that it has, and understanding what all all the limitations are, so I can operate it at its most efficient and its best way. But yeah, it looks like I've got some high clouds rolling in, um, which is a showstopper in terms of making any scientifically valid observations. But these are high thin clouds, so I'm hoping that actually as they move over my location here in southeastern Arizona in the United States, that with the full moon out, more or less a full moon out, that um, I get to see some moon rings, and if so, I'm going to go out and photograph some with my smartphone, and maybe I'll post a couple of those. Now, before I forget, and I do this 95% of the time, I am all ready to tweet the fact that I am live now, and I get going, talking about things, thinking astronomy, right? Getting into the astronomy mode. I am out of every other mode that there is. And so 95% of the time, I forget to just hit tweet like that. So I just tweeted that out. Let all of my followers on Twitter know that I am running, and maybe some of those will eventually come in. Trying to be a little bit more aggressive in terms of promoting and all of that. I'm not getting the the traction that I'm sort of wanting. Greatly appreciate those of you who are coming in on a regular basis. That is extremely awesome. Um, keep keep coming in. Keep participating. Greatly appreciate it. Um, but yeah, I'm looking for a bigger circle of friends. Now, you know, Skylius, she's been, and I don't exactly know how this works, but a huge shout out to Skylius on Twitch. It's Skyalius, Skylius, and she I don't exactly know how Twitch works, but anyway, she's been highlighted this past week or these past several days, and she's been on like every single day for hours and hours and hours, just talking astronomy and space and all that. And she's at least the one that I watched the other day. She was getting like 12,000 viewers at once, right? 12,000, 13,000 viewers. I'm thinking for me that's a bit much. I mean, how do you that's a big, I'm trying to think of this, um, like a stadium, right? I mean, she's essentially in a stadium, right? And she's up on stage with a microphone and, sort of a projector behind her, and 12,000, 13,000 people are in the stadium, and they're basically all talking at the same time. Um, that's a little rough. Uh, I, I, well, I'm not going to stop anything from happening, but that for me and for this live stream, that seems to be a little big. That isn't, sort of, the circle of friends that I'm aiming for. But you know, I just like um, everything else, I'm pretty open to whatever happens. But you know, uh, that first domino I've pushed, right? I've pushed that first domino, and um, sort of waiting for momentum, waiting for some traction here. So yeah, anybody watching this either live or later would greatly appreciate um, any kind of help in terms of sharing this around. Um, if I'm not getting the traction, I would definitely like to understand why. Um, is it the delivery? Is it the content um, isn't interesting enough? Is it the presenter? Am I just sort of a boring dude? I've been accused of that, but I've been accused of sort of the opposite of that too, being able to get people excited about things as well. So yeah, don't know yet. I'm, you know, my attitude is that I'm going to continue this because if I wasn't doing this live with all of you now, I would be doing it anyway inside of my head. So I've been I'm sort of lucky in that sense that that I don't have uh, an incredibly busy life. So 99.9% of my evenings here, I'm here, sitting at home, sitting in my office, and in the evenings, been working all day long. My brain's a little tired, body's a little tired. Just want to sit back, relax. And so, what do? I think astronomy. So it's like, well, if I'm doing that anyway, then I might as well start up a machine, get a camera, get a microphone, dig a microphone out of a box, and connect it all up, and see what happens. And but yeah, so I'm going to continue this pretty much regardless of um, if the viewership grows or anything else. I'm just it's sort of a curiosity to me. that I've uh, yeah, never had never had a lot of luck gathering a lot of support. Not quite sure why, um, but regardless, I'm going to continue. And as far as I'm concerned, this is really, really fun. As I said, I'm sitting here anyway, thinking astronomy. Don't want to necessarily do any more work. Just want to sit back, relax, read some articles, talk astronomy, think astronomy. So that's what I am going to continue to do. So consistency added with a little bit of patience and always trying to get better and better and better every single day. I want to I want to try to get a little better in terms of presentation, in terms of content. I think the show is sort of keeping on top of you know sort of the latest and greatest bleeding edge um, astronomical news. So why am I not getting the attention that I think I should? Mm, I don't know. Cheers. It's coffee night. Yeah, and Tom, you know, I, these are things that sort of just bubble in the back of my head. Really, um, ADL is a fun, casual get together of friends, and it's just in the back of my head. It's yeah. I think it's just time. I think it's just time, and as I said, consistency, persistence, patience. Um, you know what I've observed, and I'm old enough to have made this kind of observation that there are three fundamental elements to success. The first is being at the right place. The second is being at the right time. And the third, which is so those two components, if you combine those into one, it's luck, right? Being at the right place at the right time. That is luck. There's nothing there's nothing that anybody can do about that at all. But the third element, which is the thing that puts it all together, is that you have to be prepared. Okay, you can be at the right place at the right time for some kind of um, opportunity to arise. But if you're not prepared, um, then it's going to pass you by. You're not going to see it. You're not going to be ready. Whatever, right? So um, what I'm doing now, and the way that I see it, and I've experienced this a number of times, and I've also observed it many times, is that if you're prepared and lucky, then uh, success will just automatically follow. So yeah, I consider this sort of my training, my means of preparing. So when that lucky uh, um, time and place happens, I will be ready. And when I'm ready, then off we'll go. So yeah, you know, that's how I see it. And as I said, I'm doing this anyway. This is fun. This I I don't feel any kind of a obligation um, at all. This is just fun, and you know, it's become part of the routine. I've been doing this now for a little while, and it's just a thing that I do. So instead of thinking astronomy in my head on evenings, I think astronomy out loud. That's all. The only difference. So I think it's fun. So you know, best to just continue. As I said, I greatly appreciate the support from Tom, Uncle Bill. There have been a few others, and yeah, I think over time this will this will go, and it's just a matter of being at the right place at the right time and being prepared. So you know, hopefully, and you know, that actually puts the responsibility back on me to be as prepared as I possibly can be for when that time and place happens, that I can grab, you know, sort of the golden ring and um, you know, first be aware that there's a golden ring to be grabbed, and two, have the wherewithal to grab it and have the ability to hold on to it. So yeah, I think it'll happen. Um, and yeah, it's just a matter of consistency, persistence, and a little bit of patience. Cheers. And I'm trying to, you know, follow sort of the format of a couple of live streams that I watch. One is is the shortwave radio show uh, run by Gilles. He's up in Montreal, Quebec, Canada, and he does a shortwave radio show and also a computer show every week, at least once a week or so, for you know 2 or 3 hours at a time. And he's doing exactly this. He's doing. I mean, the shortwave thing is, you know, he's just, you know, he's got his shortwave radio running, and he just dials around, and you know, listens to things, answers questions, has conversations um, with people in the chat, and that's it. That's it, and that's almost that is exactly what I want to be doing here. Just, you know, the subject matter um, is just astronomy and not shortwave radio. And I see no difference between those two at all. The other um, live stream that I am trying to model off of is Rick Beato. He's or he was a music producer, also a musician, and he has pretty much a daily live stream as well, where he is doing exactly the same thing. He's sitting in his studio. He has um, a full production studio in his home, and he sits in his studio and turns the camera on and has a conversation with people in the chat. You know, they ask him stuff, um, he answers them, they make comments, he reacts to comments. It's exactly the same thing. So that's that's what I'm trying, you know, to mirror this live stream on, are, you know, basically those two things, except, you know, the topic here of course, is astronomy, and not shortwave radio, not music, but just astronomy. And yeah, so I think it's just a matter of time. Gilles has been doing this for years, and you know he's got a really nice following now. You know he'll get one or 200, well maybe 100 viewers at a time live. Rick will get you know maybe 200 or so. Um, yeah, it's just a matter of time. Being consistent, um, and also having relatively good content, I think. And as I said, I think as I do this, over and over and over again, and I think about it, um, how can I get better and better and better and better? And so that's what that is all about. So cheers. I also have the hydrogen hydroxide tonight, HOH tonight, because it is not going to be a long night. So cheers to that. One of the not one of the most amazing molecules in the universe, right in this mug. Cheers. So last night's observing session went really well. I did have a patch of high clouds move very quickly through. I just collected data through them. Um, I'll definitely see that, or at least I should see that in the data. Um, collected at least, well, I collected 200 images of M46 and 200 images of M37. I also went up to M67, did a little bit there, started to get tired. Um, and so yeah, I've got lots and lots of new data to plow through. I'm still plowing through my old data that I took on the evening of March 15th. So that's 2 week old data now that I'm still trying to understand. Um, and I think I'm on the right path. What I'm doing, um, and I'll be extremely brief because I've said this 1,000 times already, it seems. But uh, I'm trying to see how photometrically accurate I can be, and so I can make measurements. I can take images of a field of stars, and then I can measure the differences in magnitudes between stars. So I take one star and I say, okay, that one I'm going to compare to all the other ones in the field of view, and then I can compare those differences to um, uh, the magnitudes as measured by Gaia in this case, and I can compare the differences um, between those two things, and what I'm seeing, I think are some pretty significant differences. And when I say significant, I mean you know sometimes I'm seeing in the worst cases like 2 magnitudes difference. Um, in the best case, actually, I'm seeing millimagnitudes. Uh, uh, you know, so I'm trying to understand why sometimes um, my comparison is really good, and sometimes it's really bad. and it could possibly still be that I'm not comparing things right, although I've pretty much eliminated that. Um, I'm now I think I'm on a path to understanding uh, uh, why I'm seeing such a variation uh, when I compare these things. So we'll see. We'll see. I think I'm on a path. I think this weekend I will, or at least by the end of this weekend, I will definitely know. And I'm really anxious to look at this data that I took last night because the conditions were different. Every single night is unique. Um, and so, yeah, I'm interested in now doing a comparison, between the um, um, data that I took on the 15th and the data that I took last night, um, and just see what the differences are. And yeah, it's all part of understanding how to drive this scope well. It's like learning to ride a bike, and yeah, learning to ride a bike, you fall off and you fall off and you fall off, and you start feeling your balance, and then all of a sudden you're riding, and you're riding really well. So that's I'm right in, you know somewhere along that process of learning to ride a bike, and want to share it with you guys, because I think it's interesting, and it's something maybe that you don't hear a lot about. You always hear about sort of the end. This is what I've accomplished, but um, you don't really hear a lot about the struggles, and the amount of work and the amount of effort that goes into those kinds of accomplishments. You know, Dealing with astronomical data and coming up with results is hard. It's really hard, and but it's just like riding a bike, though. So, it is hard at first, and then it gets easier and easier and easier until finally you're riding, and then eventually, you do some short tours, and then all of a sudden you're on the team doing the Tour de France, and that's sort of top level. And that's what I am aiming for, even with this modest size 0.2 meter scope, um, aiming as high as I can. But yeah, this system will tell me what it's capable of, and I just have to listen. And when I hit the limit, I'll say, okay, is that an acceptable limit for what I want to do? If it isn't, then it's like, well, okay, this is as good as I can get. Uh, but I'm hoping, I mean, based on what I'm seeing, I'm seeing enough. I'm seeing enough to say that photometrically, I can get millimagnitude accuracy. And um, in terms of um, in terms of astrometry, measuring the positions, I I already know I can get sub-arc second um, accuracy. So I'm good there. I'm really awesome there. So it's just the photometry. Sometimes I'm getting millimagnitude, and sometimes I'm not. So I'm trying to understand why. And if I can understand why, then maybe that's either going to set a limitation on what I can do, or it can sort of direct me into how to make these observations. what conditions are necessary, you know, all of that. You know, that's one of the things too, you know, that scientists don't talk a lot about is how you can just listen to your data, which ultimately, of course, is listening to nature and letting nature guide and, you know, tell you things. And so yeah, I'm in the process of doing that, and it's fun. It's fun. I mean, if nothing else, I suppose it's fun. I hope that it turns into something a little bit more than just fun. But at least at the moment, it's an interesting problem to have to solve. Having to write a bunch of code, which I don't mind. I thoroughly enjoy that as well. Um, I'm a C programmer, just plain old C. I think C is, uh, you know, I've got a modest amount of experience with other languages, and C C wasn't exactly my first language, but it was my first sort of science. Well, my first programming language for science. And so I definitely have a bias, definitely have a bias towards just plain old C. But at least in my opinion, C is just awesome. It's just absolutely awesome, extremely powerful, um, and yeah, it's definitely my go-to in terms of that. So cheers to C. All right, now Tom posted on my Discord server this afternoon. I'm going to pull up my Discord server and share the screen here as soon as I get the Discord up. Get that up and loaded. Slow connection because of my streaming. All right, I'm going to go ahead and share my screen now while I itch my nose once again. Share the screen, go to infinity, hide that. We're going to go over to Discord, and Tom posted an article about a new composite image of the Crab Nebula that looks like it just came out a little while ago. Oh, where is it? There it is. There it is. And so I just wanted to talk about it a little bit. And I'm actually I meant to start my live stream over here on my smartphone. Hello, Warnock 69 XXX. Hope everybody, or hope you're doing well over there. Haven't been hitting your live stream lately. Been super busy. Hope everything's going well. I think your audience is growing, which is very cool. Very cool. Hope that's what you're looking for. But we're looking at the Crab Nebula tonight. It's a remnant of a supernova, an exploded star that they actually have a record of this star exploding back in 1054 AD. So, whoa, what is that? Like almost 1,000 years ago or so, this star exploded, went supernova, and what they've done is they've taken images from three different sources. Uh, an X-ray telescope called Chandra, an optical telescope called the Hubble Space Telescope. Yeah, supernova. And another, I think this is Spitzer. Is Spitzer a Spitzer, I think, is an airborne observatory. So they have a telescope in an airplane and they look at things in the infrared. And so this is just a composite image uh, of those three different wavelength bands, right? So this, uh, uh, so um, what this picture is showing is just a false color image of the Crab Nebula, and because they are looking at it um, in different wavelengths of light, different details can pop out. So these are really hard to do, because one of the first things that you have to do, uh, two things that you have to do, is you have to take. So I think we can just look at the individual ones. See, so there's just the X-ray, there's just the optical, and there's just the infrared, right? So you're seeing different things. So one of the two things that they have to do in order to make a picture like this, right, is first they have to line everything up. So everything um, properly overlaps. That's usually called registering an image. So you have to um, uh, um, you have to be able to know where uh, where these instruments are pointing in the sky very accurately in order to line them up. And you have to do astrometry on this. You have to measure the positions uh, of this thing very accurately in order to get them to all line up. The other thing that you have to do is you have to be able to measure what's called pixel scale. So these all these images uh, use some kind of a camera in order to um, collect the data, see the actual light coming from this object, right? And and uh, and so uh, you have to know, how much um, of an area on the sky is covered by 1 pixel. You basically need to know your field of view, right? Um, so because Chandra's field of view might be really large compared to Hubble's, and so you have to change things around. So you have to line everything up, right? You have to shrink and expand in order to get the same field of view, and that's probably why the infrared one isn't quite as detailed as the optical and the X-ray, because they probably had to, expand this up because the field of view just wasn't as great. Well, there's a lot of detail here, of course, but it obviously doesn't look as sharp. Um, and yeah, that's just because their fields of view are different, and so they've had to modify these images in order to get them all on the same scale. So once they've got them all lined up exactly right, and they've shrunken and expanded them, then they can add them up like that in order to get your final view. So one of the other things that uh, is done is choice of color, right? Because these instruments, what they're doing is they are just measuring the brightnesses of things. They're not actually seeing color. Color is uh, actually color doesn't exist. What exists is a sensitivity to different wavelengths of light, and uh, we just call things green or call things red. They actually aren't red. It's just that at that, if you see something that is, completely red, what that means is that at that wavelength or wavelength band, um, there's just a lot of light. That's all it is. So um, all these instruments just measure how much light is coming off of a certain spot. Okay, we have added the color to it, and we can choose what color to make it. Now, they didn't have to make the X-ray color blue. They could have made it any color they wanted. They could make it red, they could make it orange, they could make it purple. It doesn't matter. It doesn't matter at all. Not only that, but because fundamentally um, the images are a grayscale, right? They go from dark, completely black, to completely white, and everything um, um, in between is just different shades of gray. Well, you don't have to do any kind of a linear thing, right? You can actually have the shades of gray change change according to some function, nonlinear function. So you can bring out the faint things, or you can bring out the bright things. Hard to describe. I'm going to think about how to better describe that. Um, so there's basically the bottom line is that you can fiddle with these things a lot in order to emphasize certain things or de-emphasize other things. And so that is definitely what they've done here. So they've chosen certain colors, like a color palette, and in this case, they've chosen three colors because they have three pictures, right? So they make the X-ray sort of this cool looking blue. Now the reason why these look white is probably because those were the brightest pixels. Now, not necessarily, but probably. You would have to look at the actual, function, that they used, to colorize these things. Whoop, come back. Here we go. And optical, the same way. They've chosen, sort of a purplish color. Um, uh, Arbitrarily almost. It's sort of artistic license, right? In the infrared as well. They've chosen this very nice sort of violet um, color because in the end, what you end up with is a pretty cool looking picture. Now that is not what it actually looks like to us. If we were um, to look at this through a telescope, we wouldn't see all of these things in here because you can only see that in the X-ray, right? So we wouldn't see any of this stuff, right? We would see more like what's in the optical, right? Because that's what our eyes are sensitive to. And yeah, there's a lot of cool swirly things. There does seem to be ripples here, all of that in the infrared. So, I mean, the other thing, of course, that looking at these pictures in different wavelengths do is they allow you to see different parts of this remnant. So the X-rays usually are sort of showing off the more energetic stuff, uh, and and the optical, sort of the less energetic stuff, and the infrared even less energetic. This is more like the heat, the thermal stuff, sort of the gas and dust or the dust, right? Um, so you're seeing different parts of the nebula um, depending on what wavelength you look at, but putting them all together that way, you get a larger understanding of sort of the relationships between structures, and it's awesome, of course, very very awesome. So yeah, but making these images is a lot about art and artistic license, and trying to emphasize certain things. I could take exactly the same data and make it look almost completely different. De-emphasize certain things, re-emphasize other things, um, change the colors, make it look almost completely different. The information, of course, doesn't change, but you know what we're actually seeing would. So, but that's a very very cool shot. The other thing that I saw a while ago were these movies that they made, and I think this is optical and X-ray information. Now, I don't think that this is going to show very well on the live stream because I'm uh, oh there's even music, which I'm gonna mute the music. But we can let's see if I can go to full screen here, and I can just play this over and over again. But is that cool or not? You can sort of see. I mean, it's probably hard to see on the live stream, but I do have a link to this on my Discord server. So take a look at it live, um, and you can see that there's. I'm not quite sure how long of a time span this is. Probably several years, but you can see that there's a lot of shit going on there for sure. Wish this had a wish this had a easier replay type of thing. But you can see it expanding, all the stuff expanding. You can see these ripples, like these waves in a pond. Cool or what? Well, That's coming off pretty well on the live stream. Yeah, that's not too bad. That's not too bad. So yeah, I'm pretty sure that this is the X-ray over here, and this is the optical over here. So there's a lot of action. There's a lot of action there for sure. Very cool. And this cloud is, slowly, well, relatively speaking, expanding. Um, so, it's getting bigger and bigger and bigger over the years. And yeah, so very, very cool. Thanks, Tom, for suggesting that for our sort of topic tonight. Just keep in mind that these images do contain a lot of scientific information, but it really depends on how you look at it, and how these images are constructed. Let's see. There's a bigger. Here's a bigger image. Take a look at it. Pretty big. Nice colors. Pretty nice. Look at these. Look at these weird structures in here. Pretty cool, huh? Amazing. Absolutely gorgeous too. Good choice of colors, but yeah, I would like to see this, with some completely different ones, and see, what things pop out, uh, and what things don't. But it's very, very cool, regardless. Let's see. Does it say anything else here? Just, I think it gives a little bit of history in terms of Chandra and when the Crab Nebula was first observed. Yeah, 1054 AD. So it's a composite of X-rays, blue and white, HST, excuse me, purple, and NASA's Spitzer Space Telescope. Okay, so Spitzer is actually in space. It isn't a airborne observatory. It's actually in space. It's an infrared telescope, though. It sees things in the infrared as opposed to the optical or the X-ray. But it's very, very cool. Pretty amazing place, for sure. Cool. That's the Crab Nebula is also a Messier object. It's actually Messier 1, M1, and yeah, it's still it's getting a little bit hard to see now, but definitely in the wintertime, check it out for sure. Uh-oh, I've tangled my cords again. I always seem to do that in the worst possible way. Guess I'll have to work this out afterwards, because doing it one-handed, trying to hold a microphone and trying to untangle things, it just does not work. It just does not work. So I need to give up before I mess it up even more. So let's do just a real quick object of the day. We'll go to our favorite random.org site to choose our let's do an NGC object, huh? Now last time we did an NGC object, we really uh, got a little bit of a bomb with NGC 2707, but let's try it again. There's 7,840 NGC objects. And yeah, JWST, when it launches, now I'm saying when it launches, because it, at least as far as I'm concerned, it definitely will. All this, hand wringing about it being delayed and everything, who cares? Who cares? I mean, if there's a will to get it launched, then it will. My only requirement is that you had better be sure that it is going to deploy, because you know having a delay, as far as I'm concerned, is not any kind of a disaster at all. I mean, yes, it's a setback, and it's um, puts other projects, sets those back as well. But it is definitely not a disaster in any way. What would be a disaster is if they launch this prematurely, not being absolutely sure, or at least as sure as they can possibly be, that it was going to deploy and work. Um, Hurry up, get it up there because we're running out of money. I'm running out of time. Baloney. But if they were to hurry and do this, and then it not deploy and not work, that is a disaster. So get it right, take the time, um, get it right. Launch, deploy, and enjoy. Right? That's my attitude. But yeah, um, um, JWST will replace Spitzer in terms of space-based infrared observatories. So looking forward to JWST. Just going to have to wait a little longer. Get it right, no problem. All right, so let's do a quick object of the day. We're going to go for the NGC catalog, the new general catalog, and let's hope that we actually get an actual object tonight. We have I was unaware, as far as I know, I was completely unaware of the fact that there are NGC objects that are not uh, non-stellar objects, sort of unidentified or misidentified non-stellar objects. So, and our last one, NGC 2707, is one of those. It turns out that that's a misidentified star. So very, very cool. So let's hope that we get an actual non-stellar object this time. Drum roll, please. NGC 1876. So let's go to Simbad. What is it? Man, I forget these so quick. 1876. Now, the NGC objects are sort of in general in order of right ascension. So 1876 um, uh, is relatively, you know, this side, you know, close to zero. Well, not close to 0 hours, but I mean, it's not even halfway. So I'm thinking that it's going to be what, around maybe 3 or 4 hours right ascension. So 1876. Right, right, right. Yeah, yeah. Yay! It's a cluster. Now it says a cluster of stars, which doesn't necessarily mean like a galactic cluster or a globular cluster, but just a loose cluster of stars. And yeah, okay, it's at 5 hours, 13 minutes, 19.4 seconds. But look, it's in the southern hemisphere. I've got to sneeze. All right. So this is only visible if you're in the southern hemisphere of this planet. So me being in southeastern Arizona, no way am I going to be able to see this. Um, Pretty small, 1 arc minute across. So pretty small, pretty well, yeah, not incredibly bright either. B and V are both in the visible range, uh, but magnitude 11.54, 11.71, pretty faint. So this is just a very, very faint, as it says, cluster of stars. Now, probably, these stars are associated with one another in that they're moving in the same direction at basically the same speed. Probably, as far as the theory goes, probably formed in the same place about at the same time. So maybe they're about the same age. They can be different masses, though. So at least how that theory goes, they're going to evolve differently. But not a lot of information about this guy. Look at that. In the past 20 years, there's only been 10 references to this object. So this is a much neglected NGC object. Yeah, not much here at all. There's not even any, there's no distance information. There's not much here at all. Let's go over to Ned really quick and take a look. See if we can get anything else about this guy. Some images there. We'll take a look at the images pretty soon. Yeah, not much here. Not much here. It's a much neglected little cluster of stars. They basically know where it is and a little bit of idea about how bright it is, and that's it. Man, let's see. Let's look at the references. Let's see if there's anything sort of specific. Maybe there are some eclipsing binary stars in this cluster, maybe, sort of implying that there. So it looks like it's in a region of a cloud of gas and dust. I'm seeing H2 regions. Looking in the gigahertz. Is that not quite sure? That's not submillimeter. That's shorter than that, isn't it? General catalog of extended objects in the Magellanic System. Synthesis imaging of dense molecular glass in the N113 H2 regions. It looks like maybe this cluster is part of the Large Magellanic Cloud. Formation of stellar clusters and evolution in molecular clouds. So yeah, boy, not a lot of info on this guy at all. Let's take a look at the picture. That's probably best because, we're running short on time here. So too much more of your time. Although, talking and thinking astronomy, man, I could do that all day, every day. Oh, I am. So this is a very overexposed overexposed image, but yeah, this definitely looks like it's in a pretty dusty region. I'm seeing dust and gas. Let's really zoom out and see. This looks like it is in the Large Magellanic Cloud. Yep. All right, well, cool. This is the Large Magellanic Cloud. This is a dwarf galaxy. It's a companion galaxy to our galaxy, um, um, the Milky Way. There's the Large Magellanic Cloud. There's also the small Magellanic Cloud, sort of nearby. And it looks like that this is possibly, I would say likely, a cluster of stars associated with the Large Magellanic Cloud. So that's pretty cool. We are looking at a loose, open cluster in a different galaxy. So that's pretty cool. That's very, very cool. Not quite sure, you know, these kinds of things when there isn't a lot of information about them. I see that as an opportunity. It's like, well, hey, let's take a look at this a little bit harder, see what is going on. I sort of like the so yeah, it's just a cluster of stars in the Large Magellanic Cloud. I like the NED image that I saw. Let's go back to NED and see if there's look on images here and see what we've got. Fits image. Can we do this? Wow, that's all we've got. That's all we've got. So yeah, hard to tell, but it sort of looks like, this is really, really hard to tell. I don't have a way of zooming in. Do I? Yeah, I do. Hold on. Hold on. Here we go. We can sort of zoom in on this a little bit, but what I'm seeing is, this looks like the cluster of stars here, maybe out here, but look, I'm seeing these interesting rings, of I guess I assume are clouds of gas and dust, but that's kind of interesting. Maybe some winds are blowing some bubbles. Who knows? Hard to know. But yeah, this is a much neglected, not paid attention to much cluster for sure. All right, let's exit this guy. Uh-oh. And let's see, let's go back. Let's go back to this guy. Whoop, did I go too far? I did. NGC 1876. Not much there. It does have a couple other names. So it has been cataloged in small ways. Let's take another quick look. Yeah, spectral line survey. General catalog of extended objects in the Magellanic system. Let's just see if we can get any joy out of this at all. Go over to ADS, see if there's a paper on this. Update the small Magellanic Bridge and the Large Magellanic. Extended objects that were constructed by members of our own group who present the results of subcategories containing 1,445 emission nebulae, 3,740 star clusters, 3,326 associations. So this would probably be one of the associations, I would think. So let's see. Let's look at the actual paper here and see. We can do a search for 1876 and see if it's even mentioned. Sometimes they are, sometimes they aren't. 1876. Nope. Not mentioned at all. Arr. Let's see, what are they talking about here? Okay, so probably this is a catalog that you'd have to dive into, because this is just sort of a general overview of the catalog itself. Here's my machine. Okay, so this is where they've located all the things in their catalogs. This obviously is part of the Large Magellanic Cloud. This is part of the Small Magellanic Cloud. Um, so yeah, we would actually have to look at the, let's just see, angular distribution of H1 shells and supershells, stellar associations. So probably I would say, come on. Come on, come on, come on. Gene. So probably, come on, machine. Probably 1876 is either part of this or part of this, right? Because it's saying, yeah, these are the H1 shells and super shells. Maybe those are the bubbles that we saw um, in the picture. These are the stellar associations. These are the clusters. So 1876, damn it, is, man, what is wrong with this machine? Come on. I am not touching anything and it's flying all over the place. Arr. Um, so 1876 is probably either in this group somewhere or in this group somewhere. And yeah, this catalog, I'll bet, is online and we could find it if we wanted to. All right, well, cool. I think I am going to get out of here for now. I'm actually going to go have dinner. Whoop. Wasn't quite sure if I was going to be observing tonight or not. It definitely looks like I am not. I can actually go over here to my satellite view and take a look at the most recent infrared image from space. And yeah, clouds, high, thin clouds rolling in. So the best I'm going to do tonight is maybe some nice moon rings, which would be very, very cool. So hope you enjoy those. And yeah, I think I'm going to get out of here for now. It was cool looking at a much neglected, much barely even known cluster, NGC 1876. Three cheers for 1876. Yeah, part of the Large Magellanic Cloud. It's what's what is not to be cool about that? I think that's very, very awesome. We need to study it more. We need to find out how far away it is, how big it is, what kinds of stars are there. Those are stars. That's a cluster of stars in a different galaxy, right? That's very cool. All right, I'm going to get out of here for now. Hope everybody has a great evening and a great day tomorrow. Make sure to subscribe. Spread the word. Spread the word. I want some traction here. I want to have a nice little crowd. Not looking for 13,000 viewers, right? I'm looking for a respectable size so we can have a nice conversation about the science of astronomy. And I'll be here every night no matter what. So stop in when you can. And yeah, this is just fun. Just fun. You know, talk astronomy for an hour or so. Very, very cool. All right, I'm going to get out of here. Have a great evening, great day tomorrow. I got to get rid of this. It's driving me insane. It's going to be gone this weekend. Uh, Driving me insane. All right, time to go. I will see you on the spin less than 24 hours. Okay, take care, everybody. Bye.